Hello, it seems that everybody that wants to hear us here. So, right now, Bartlomeij is going to talk for us, and we'll talk about event state function. So, I hope you all enjoyed this talk, and yeah, it's on you.
How do you grow as a programmer? I have my favorite way of doing this. I typically start with lots of small projects. Usually, I'd pick a new technology, start a project, finish it in about 1 to 2 weeks, publish it to GitHub, tweet about it, gather feedback, and begin with something new. I decided that I want to learn functional programming this way. And I had a plan. Actually, I wanted to build a website in a functional programming language. Before I'd get to this knowledge in functional programming language, I wanted to build some few smaller projects, maybe 2 to 3. During my journey, I've learned a thing or two about functional programming, and I want to share it right now. Actually, I want to fill out this little list. Why you should learn functional programming, what can you learn from it, and especially what we as Ruby programmers can learn from it. So, the plan is set, let's go. I've picked Haskell as my language. Now a short disclaimer, during this talk I won't speak about features unique to Haskell. I won't speak about Haskell's type system, which is amazing by the way and is actually very, very useful. I won't speak about how amazing it is to write in a language that has lazy evaluation. It's a completely unique experience, and I recommend it to everybody. But I'm leaving these 2 things to check out for you. I will show some Haskell code, but with this, I'd like to generalize over whole functional programming, over functional programming as a whole. Now, what is functional programming? My friends asked me once. So I said, it's about functions. I can define function very easily, and actually, let me do it right now. I could write a function for greeting somebody with a certain verb, and in this way I could greet the world with hello. Pretty standard thing. I have some special tools with dealing with functions too. For example, carrying or function completion. I could define a pirate greet, which would greet people with and if I provide only one argument to this function, it will still allow me to define the second argument later, and it will work. This is done via carrying. Isn't it wonderful? Isn't it unique? And do we have something like this in Ruby? It turns out we do. I could define a lambda in Ruby, and later on I could just invoke a carry method, send an R there, and would have my pirate greet function. So yes, Ruby has it too. Then I've seen in Haskell this wonderful way of assigning unneeded arguments to an underscore. And it's here, and then I noticed it's also there in Ruby. And in Haskell, there's lots of stress on map and inject functions, and of course there's also lots of stress on them in Ruby. So it turns out maybe it's not about functions after all. Maybe functions are just a tool, or used just as a tool to accomplish a certain goal. Yes, there's a set function there. So what is functional programming about? Let's try getting it by just feeling how it is to write a program in a functional language. Let's try writing a game, a tic-tac-toe game. Typically, we'd start with an empty board of nothing. We'd want to assign something to this board at a certain point, but it turns out it's by default impossible in Haskell. Haskell, but by default, prohibits destructive modification. If we were to introduce another element to a list, for example, if we were to replace an item at a specific index in a list, in a functional language, if we cannot modify something introduced with destruction, we would return a new object with our changes. So, in case of a list, would get the beginning of the list, insert our object, and return the rest of the list. We could imagine doing something similar for a two-dimensional list, and our tic-tac-toe program would create such a list and place an X on it, and possibly feed this result to another function that would replace something, and this result, in effect, would go upper level and another level, and our whole program would look just like one big expression. That's something different, isn't it? We're used to defining how the state of our program changes in small steps along the way. So we would modify our board and modify it once again and change the state once again. And essentially, this is what imperative programming is about. Describing in steps how the state of the program should change so that we achieve the desired result. When we have one big expression, that is, when we deal with functional programming, in effect, we don't think about how the program state changes. We are interested in the desired result. We specify what our desired result should be. And that's because functional programming is a subset of declarative programming. And that's the difference. Declarative programming has some unique properties. So I'd like to talk about them very quickly, and this is something you'll definitely encounter when reading more about declarative programming itself. So the code is mostly, the data in the code is mostly immutable, as I've said before. You cannot perform destructive modifications. Now, the function body is usually stateless, so it doesn't reach out and modify some variables out of its scope. It also doesn't perform any side effects. So functions usually, mostly, don't throw in exceptions, don't reach out to some I/O operations. And in fact, these terms are kind of difficult to define. I've given you a colloquial definition of each of them, but if we get to pinpoint an accurate description of each of this term, it would be more complex and also out of the scope of this talk. Maybe for just a brief feeling how it would be, let me analyze more deeply the last one, the referential transparency. So referential transparency is most commonly thought to occur when we have a function that takes a set of arguments, and for the same set of arguments, it returns always the same result. Now, this is most common view on this, and it is not as it used to be originally. Originally, we would speak about referential transparency when we could replace the expression with the result of the expression. Very, very subtle difference, but if you get to analyze it more and more, you would run into some inconsistencies. Now, referential transparency actually is a term borrowed from analytical philosophy, and I'll talk about it later on during my talk. Now, personally, looking at this distinction between declarative and imperative programming, I've came into such opinion that it looks like this. The boundaries are kind of blurred. So some languages focus more on transition of states, like C. Some languages focus more on describing what the result should be, like Haskell. And some languages, like Ruby, provide tools, mixed tools from both of the worlds. And actually, I could write something to my list. You should learn functional programming so that you know better the declarative side of Ruby, so that you have some secret weapons, secret tools like this currying, like recursion and masterful use of map and inject. Good. But I wanted to write a web application, so let's go to this. You remember my tic-tac-toe? I wanted to move it to the web. So I've tried it, and I've run into some problems at the beginning. I couldn't perform destructive modifications. Destructive modifications are frowned upon, but my application, when as it was running, it encountered lots of state. So new players would appear. They would start new games, new tic-tac-toe games. They would place new moves, and state would start flowing in, and I'd have to manage it somehow. So my first idea was to move it to the database, and it's a good approach. Unfortunately, I decided to do it too much. So during a single request, I would put into database and query it very frequently, even for the same object, essentially storing state in the database, or even worse, using the database as a simulation of a variable. Very, very bad. And look at these arrows. They kind of look like the state example I've already shown you, so modifying the state. And I'm not really writing a functional program right now. It took me about a week, and I had to scrap this code and start anew. I had a new plan to replace database with session. Now, I don't think it was a good plan, because I still started writing into the session and reading from session, and you know the story. So I still was thinking with state and lost another week and didn't learn my lesson. And I have another candidate for my list. So it is very difficult to get into the mindset of a functional programming language, and there is room for improvement. So you can help and maybe take some energy from the Ruby community and go into community of functional programming languages and try to improve it, try to make it more approachable. This community is very powerful, and I'm constantly impressed by how quickly the functional programming languages can develop. They are able to release new versions at impressive speeds. They could be, however, improved in terms of being more approachable, more easy, more understandable. And it is very beneficial for your development to contribute, and it is also very, very satisfying. That's my second point on the list. But I'm still left with my problem. I had another idea. What if I will try to foresee every possible state change, every possible object creation before running my application? Essentially, I would create some initial data structure, and my state changes, and it would wrap around all my state changes and maybe make it more functional. Let me show you something, maybe on a bit simpler example. Here's a 1-0 application. It has one global state, actually a counter, and in fact, I didn't show one important slide. This one, it's live, you can play with it at 10.heroku.com. And so you can see on your own how it works, but I'm going to demonstrate anyway. There is this counter, and all users can vote on this single counter. By pressing yes, you add one vote. By pressing no, you subtract it. Should be simple to write in Haskell, right? So let's dive into the code. Here is the Haskell application that stands behind this website. Maybe I'll go through the whole program very quickly and saying briefly what each line is about. So first line and import modules are just some quick initializations. Now here is something interesting. This is the data structure I was talking about earlier. So as we see here, there is only one point of change, this global counter. And I'm also declaring on the side a channel based on HTML5 technology, server sent events. That's maybe a quick digression. Server sent events are just similar to WebSockets, just one directional. The events flow only from the server to the client. So here I'm declaring this channel to allow me to push events from server to the client. Now I'm using YSOD web framework to allow me that allows me to set a web server on a specific port. Now, here is something familiar, routes. So every web framework seems to have it. And this is a method that allows me to process calls from the client. When I send a vote, this method gets hit, and here is the modification of my global counter. So if a value is yes, I jump into the else clause and return a function that will increment the score. Otherwise, it will decrement the score. Get receiver for sending information about the event to the client. And my homepage, which is essentially just an HTML code with some JavaScript and CSS. In 100 lines, which is not bad, and I was quite happy with my application. And I got my problem kind of solved. But there is one thing that still left me concerned. I was writing things to this data structure, and I was reading things back from this data structure. And I was writing and reading back, and I still haven't eliminated state, because the state exists in the external world, and it had to be modeled in my application too. So sure, my application feels more modular and maybe is a little bit more clear, but at what cost? It took me enormous effort to go through all my failed attempts and to devise this new one. And actually, I had a plan to create 4 web applications and not 2 very mediocre ones, which I did. And to deploy this thing, it was a nightmare. It took me 4 virtual machines. And actually, I don't think a Haskell was a good idea at this point. And in fact, I have enough of this technology, period. I decided to take a break from Haskell, and I came back to Ruby. But I've noticed a curious thing. When I would approach a new function and I didn't know how to write this function, I wouldn't start thinking about what should happen in the function body. I would start thinking, hey, what data should flow into this application, into this function, and what should it return? And maybe later start thinking about the state. So this was kind of making my programs a bit more modular. Moreover, when I would encounter a function that would depend on some external state, I wouldn't even think about it. I would just approach it and refactor it. I would possibly extract the state to a parameter so that my function doesn't rely on it, essentially performing a dependency injection. But I didn't think about it. I just did it. It was just somehow embedded in my fingers. If I saw a class that would require lots of variables, depending on a lot of context, I would be also very afraid, because I would fear that I would never understand and could encompass all of this context. I would try to extract as much of the logic as I could to a separate class, doing something like this. Essentially, performing actions so that I'm still respecting single responsibility principle. But again, I didn't think about it, I just did it. And so on and so on. My classes in Rails applications would become more modular. I would create more domain and concerns classes. If I had to communicate with some global objects, I would possibly do this via wrappers that would constrain me. I would definitely try to limit singleton objects, or maybe static methods, or fight global state on a whole. And This isn't anything that new, because these are just basic object-oriented principles. However, I didn't have them in my mind. I kind of had them in my fingers, in my muscle memory. Just because I've been to a functional programming world, I've seen how programs without state, with a limited state, can function, operate, and how easily maintainable can they be, and how bug-free they can be. And this is why I also wanted to limit state and manage it the best way possible in my imperative code. And this is the final point on my list. So what I've learned in the functional programming world is better state management. I was very happy with it. And I think, actually, I owe some apology to Haskell. I was angry at Haskell because I was mad how difficult it is to work with state in this language. But I've forgotten about two things. Firstly, I've picked a difficult problem. So a web page essentially has to deal with lots of state. Users input flow all the time. And functional languages deal with it this way, by remembering all the time about all possibilities. And it is difficult to work with state in functional programming languages, but that's the way they work. There's another thing. Some people can handle it. And there are people who have such level of experience in functional programming languages that it is doable for them. I wasn't experienced back then. And there are businesses who work with Haskell, for example. There are web-centric businesses who work with Haskell too. There are whole websites written in this language. Sometimes, maybe more often, this technology is mixed with, for example, Ruby, and the application can be built with Rails, and some web service can be built with Haskell. So, and I'm definitely not mad at Haskell right now, and actually I'll be very happy to come back to this language at some point, and I'm very excited by Haskell. If you're excited by Haskell, let me show you some resources so that you could start if you're interested. There is a great book, Learn Your Haskell for Great Good, which introduces some very advanced topics of Haskell and functional programming in a very cute and funny way, with lots of pictures and actually a very good plot. Learn Your Haskell for Great Good. The web framework is also there. If you would like to build a website in Haskell, it's there waiting for you. There are lots of other web frameworks, but this one is well documented and has an O'Reilly book. There are some other resources I'm listing there, maybe so you can later download the presentation and browse the links. There is a blog that shows news from the Haskell community. There's haskell.org website. There is my GitHub account where I put some smaller programs in Haskell. Now, functional programming languages are becoming more and more popular and gathering more and more attention. Here, John Carmack says that lots of flaws in software development in imperative programming languages come from the lack of understanding of state, of context, of program context. In his blog post, he recommends also playing with functional programming languages. Another person that I'd like to introduce is from a bit older times. This is Willard van Orman Quine, and he is the author of the referential transparency term. Now, he was an analytical philosophist from the 40s to 1980s, and there's a very nice example of how to understand referential transparency. Let's say we have a sentence like this. The Scottish Parliament meets in the capital of Scotland. Once again, the Scottish Parliament meets in the capital of Scotland. What can we do with this sentence? Let's say we can change the Parliament to Scotland just to Edinburgh, and we'll have the Scottish Parliament meets in Edinburgh. Did it change its meaning? No, it didn't. We say the Scottish Parliament meets in this part of the sentence is context independent, is referentially transparent. At this point I thought, hey, no big deal, all sentences would be like this. So let's try another one. Edinburgh has been the capital of Scotland since 1437. Let's convert it. Edinburgh has been Edinburgh since... No, it doesn't work. So some sentences aren't referentially transparent. Now, Quine thought it's very important, if we want to conduct any research on the language, to have a precise tool for describing what we exactly want to reference. Now, he claimed that our natural language is not enough. When we say the capital of Scotland in our colloquial speech, in our day-to-day speech, we mean at once the current capital of Scotland, Edinburgh, and the whole aggregated capitals of Scotland, the current, the previous one, and the whole idea of the capital of Scotland. In our day-to-day speech, we can deduce from context which is which. Quine said, in research, we cannot do this. We should target one meaning specifically, this or this. This is kind of analogous. We can draw an analogy between these and imperative and declarative programming languages. In imperative languages, we have easy tools to work with context, and they are easy to work with on a day-to-day basis. In functional programming languages, we may be able to target precise meaning at a specific point, but at some cost of difficulty. But even when you spend a little while in this functional programming world, you leave it with an insight on what the imperative world really is. It is an opportunity for you to grow. And we come back to the concept of growth. So let's revisit this small list. So we've come to this, that learning functional programming gives you an ability to know Ruby better. To know better its declarative side, to have some superpowers, ability to use recursion, ability to use higher order functions, to use map inject, and know about some curious stuff like carrying. Functional programming languages are also an opportunity for you to develop yourself, to grow. You can contribute to an awesome community, and it's great to, and it's a very and it's very good for your growth. And most importantly, staying in a functional programming world for a while gives you an idea of how managing state can be done properly, how you can at once think about all possibilities, and how your programs can be more modular and better organized. You learn better state management. And this is how functional programming helps you grow. Question time. Do you have any questions? Yes? Mm-hmm. Mm-hmm.
Hey, this is how you can do this in Ruby. Was actually probably one of the best I've ever seen, ever. I've seen it a lot of times. And actually, you've actually explained why people can't test, because they don't understand about all the state. People try to inject all that state in there, and they get confused whenever they start learning how to test. The way you explained it, I'm going to steal it. I am. It's mine now.
Feel free. I'm very happy to hear it.
All right.
Thank you. Any other questions? Are there any other questions? Oh. It seems not. Thank you very much.
This is a pirate, which is a pirate in Dutch or in Flemish. So this is for you. Thank you very much. You also get a glass, which fits with it. Do you want us to keep it for a while and give it to you this evening, or will you take it with you? Because it's
Yes, it would be perfect. Can it be done this way?
yeah. That's